Jujutsu Kaisen is often accused of having a confusing power system. There's no better example of this than Gojo's Limitless. We even got these explanations, like this is supposed to clear anything up. And with the manga concluding, I thought no better time than now to finally quash the confusion. Now I'd be remiss not to mention that just as I started making this video, another channel had the same idea, so I've linked Funimation's video in the description. Watch it first, it's really good, really informative, entertaining. Now, Gojo says things like,
convergence, divergence. It's sort of like a convergent series of infinite numbers. This one is the divergence of infinity.
But what does this actually mean? What is the divergence of infinity, or is it just a word salad? So first we need to look at what a mathematical series is, and what it means for it to converge. Suppose we have a sum. Now don't be put off by all the maths if you've not seen this before. This is just saying we add up these terms according to this rule, from 1 up to capital N. We'll call this a partial sum, but what happens if we keep adding infinitely many terms? Well, we get what's called a series. In this example, we're just going to keep adding like this, halving what we add each time. And look at how we fill the square, halving the remaining distance with each term. But we never quite fill the square, although the gap is getting infinitely small. And that square has an area of 1. And so we'll say that this series converges to 1. Now, I'm going to define all of this more precisely and explain what all of this means. But if you're not interested in the exact mathematical definitions, feel free to skip ahead. I'll have it timestamped. It's not essential. So, what does it actually mean to add up to infinity? Remember our partial sum Sn was what we get when we add the first n terms. Well, we say the infinite sum is what we get when we look at the behaviour of these partial sums as they get more and more terms. Formally, the infinite series converges to a limit, say L, if, for any small number you like, which we've called epsilon, these partial sums eventually get within epsilon of our limit, and crucially, stay that close to it. So taking our last example, it might take a while, but for any epsilon, we are eventually less than epsilon away from our limit. In this case, our limit was 1. Put simply, the gap between the partial sums and the limit gets arbitrarily small. That's all that this stuff is saying. But what if there is no limit? We say any series that does not converge diverges.
This one is the divergence of infinity.
So an obvious example would be if we keep adding 1 forever. Clearly this has no limit. We eventually pass every number. Less obviously is what's known as the harmonic series, where we keep adding the reciprocals of the positive whole numbers. It turns out this thing just keeps growing forever with no limit. So this is also a divergent series. Now I should mention there's another type of divergence where we don't go off to infinity, we don't get near a limit either, we kind of just jump around. So if you think of the series as representing the distance to Gojo, so in this context, this series here basically corresponds to just teleporting around him without even trying to approach him, so we're just going to ignore this case. But how does any of this connect to Gojo and infinity? Well, let's look at the example that Gojo himself gave.
What the hell is this?
Infinity. It's Achilles and the Tortoise. Read a book, your stupid is showing.
Well, what is Achilles and the Tortoise? It's a form of Zeno's paradox which says imagine Achilles is racing a tortoise which has a head start. The paradox says Achilles can never catch the tortoise because as soon as he's caught up to where the tortoise was, the tortoise will have moved a bit more. So Achilles needs to catch up to that. By which time the tortoise will have moved a bit more. So he needs to catch up to that, and so on. Forever chasing where the tortoise was. Now since Gojo is stationary, we can just imagine this from the tortoise's point of view. He just sees Achilles running at him, never catching up since he needs to pass through infinitely many points along the way. And you just see a man sprinting at a reptile. Now this isn't really a problem. I can divide the space between you and me infinitely. That doesn't stop you from being able to punch me in the face. So let's look at why this is flawed. Zeno's paradox is usually framed with an arrow. Suppose Sukuna wants to fire an arrow at Jogoat. Zeno's paradox would say that the distance between the arrow and its target has to be cut in half, and then halved again and halved again and halved again, infinitely many times, so it never reaches its target. Let's look at the distance travelled and the time it takes to pass through these infinitely many halfway points. Well, we know the series. We've already seen that this distance series converges to 1. And look at the time series. Supposing the arrow travels at a constant speed, that means the time it takes to halve the distance is also halving each time. So the time is also converging to 1. That's the resolution of the paradox. The time is convergent too, which means we can cover those infinitely many points in finite time. This is known as a supertask. In particular, once we've passed the limit of our time series, in like real time, we've hit our target. If that's unintuitive, think of us as being able to get through infinitely many points infinitely fast, so it cancels to finite time. Now this time we're going to shoot the arrow at Gojo. And here I've supposed the time it takes to halve the remaining distance never changes. So it always takes half a second to halve the remaining distance, no matter how far is left. This time series diverges. So now it does take infinite time to get through those infinitely many points, so we never reach the limit. We can get arbitrarily close, but we can never quite reach him. So the real power of infinity is that you are slowed, so that the time series diverges. Another good way to visualize this idea is to consider a distance time graph. Now recall speed is distance over time, so it's the gradient of a distance time graph. So again, if we suppose that every second you halve the remaining distance to Gojo, this is just what we've already seen, but now we have a time axis. I can now smooth that out to this function, and we can see this indeed has an asymptote at a distance of 1, with the gradient also approaching 0, which means you slow down towards 0, but never quite stop. So we could say that Gojo acts as an asymptote. It's worth noting you have to be slowed down really quickly. Remember the harmonic series from earlier? Recall that this was divergent. So suppose Gojo slowed you, so instead of it being a constant time to halve the distance, it now takes constant time to cover each term of the harmonic series. Well, although that's slowing you down infinitely, is your speed, which is the gradient, is slowing to 0, you still hit him, no matter how far away he is. So to have infinity is not actually enough to say you're slowed infinitely, you specifically need the distance to converge and the time to diverge. Now of course Gojo's other techniques are also described in like mathematical terms.
When I amplify my limitless technique, I get what you might call a negative natural number.
But that is just a word salad. So the next time someone tries to tell you that infinity creates infinite space, you can tell them all about the tortoise. If you feel like you learnt something, drop a sub or a like, it goes a long way. Thank you. Bye.